everybody with me so far? I mean, this is just identifying from the problem all the different parts and putting them in. So we're going to start where we want to end, which feels like we're cheating, but you really should be used to this from trigonometry. Again, don't you kind of know where you want to go? So you can start from where you want to end and work backwards and then work forwards until they meet. Then you can write the whole proof down. You should have maybe done that sometimes with trig identity proofs. Start from where you want to be, work backwards, work forwards, pray to God they actually meet. Or just write, a miracle occurs, or hope the teacher doesn't really grade the whole thing. Right? Look, it works. Can I work with the inside here a bit? Can you do anything on the inside? Is there something I can do? What does it want me to do inside? It wants me to subtract. So how am I going to subtract this? How do I subtract those? LCD. So what's this guy need? 3. So then we get 2 plus 4x over 3 minus 6 over 3. Is everybody with me so far? This is the nice part. So then what do you get? I get 4x minus 4. Once we get to where we're going, you'll see you'll do the same thing every time. You want to get to somewhere. Let me see if you guys notice what it is. I can multiply by 3 now. Why does that absolute value not freak out? Because it's positive 3. Who cares? So I can multiply by 3, both sides. So then I get 4x minus 4. Absolute value is less than 3 epsilon. What else can I do? Yes, so I can divide by 4. Now, this is really, really kind of cool because what was this? This was that whole thing right there. This is the 2 plus 4x over 3 minus 2 less than epsilon. What's this one? What was A? What's A? 1. That's where I want to go to. So isn't this one say x minus 1 less than delta? And what did we just end up at? So what do I want to let delta equal? Yes, 3 epsilon over 4. Now this should be expected. They could change their value of epsilon. So my value for delta should be dependent on their value for epsilon. Whatever they say epsilon is, I just make delta at most 3/4 of it. And then I'm guaranteed to always live. Here's the thing they set up. I'm guaranteed to always live within there. Now, if that wasn't really the right limit, this shit would not have worked out to here. I would have never been able to get to here.
4x minus 4. Why is 4 here? 4x minus 4.
Here's 4x. And then 2 minus 6 is negative 4.
2 minus 6.
Yeah. You put these, we got the LCD. So you can just put these together. What's 2 minus 6? Negative 4. And there's the 4x just sitting there waiting. He had no x's to go with, so he just stays the same. Aw. The 2 minus 6 I could put together. I like it. So, what I do now, to really do the proof. This is all side work. If you do this on your paper, you just put a little dotted line around it. That is just constructing delta. That work seems too easy. And we're also kind of like starting where we wanted to end. But that's how we do a lot of things, believe it or not. This is a construction. I just constructed what I want delta to be. So now how do I do the actual proof? Well, I come back and do exactly what it says. So given delta equal to, where'd it go? 3 epsilon over 4. If x minus 1, so right here, do you see what when this is true, I got to show that this is true. If x minus 1 is less than 3 epsilon over 4, now guess what I do to recover this? I just do all that backwards. That's the actual proof, though. It's sort of like starting at the answer and working your way back up. And then what are you going to turn into your teacher, though? You're going to turn that shit in this way. Right? If I started the answer and work on it and eventually get back to the question, what am I going to turn in? I'm going to start here and go this way. That's exactly what we did. We started here and went that way. If the proof requires me to start here, when I am this close to x, to 1 on the x-axis, I got to show that I'm as close to f of x as the guy wanted me to be. So I got to just work everything backwards. So here I'm just going to start putting, multiply by 4, divide by 3, split it back up, and then I can just rewrite this as 2. And now I've got my f of x by this L less than epsilon check. When this is true, that leads to this being true. That's the proof. You've already done all the work when you do the side work, but this isn't the proof. Okay, maybe. So there's several ideas going on here. The idea of close is huge. But I use these epsilon deltas to help me define close. So it shows up in a lot of theorems because the idea of closeness is huge throughout all of mathematics. It's just a way to more formalize what close is. Kind of freaky. So on that sheet I just gave you, there's a problem at the bottom for you to try. And I'll give you a little hint to get you started on this one. Actually, I don't even have to give you a hint, really. It's exactly like this one. Exactly the same thing. So look what I did first on my side work. I just factored and reduced this. So let me make sure everybody's on the right track to begin with. What is f of x? In this problem, what's f of x?
2x squared minus 50
Yeah,
over x
2x squared minus 50 over x minus 5. What's a? 5. And what's L? 20. So those are the important parts for you to keep track of. There's an example right above it, just like what you got to do. So give it a try.